Okay, one other thing that I thought I really need to make a video on is partitioning a line segment. We've done this idea several times now. We've had questions on it on the last two tests. I can guarantee there's going to be another question on this test, because I would still say in both my class and Ms. Oswald's class, less than 50% of everybody is getting this question right. So, partitioning a line segment. It's actually not something that's, I would consider, a hard idea, but a lot of people aren't doing all the steps in order to get to the final answer. When we are doing a problem like this, so we're trying to find a point that is on the line segment that's containing these 2 points. So there's a line segment, QS, and we're trying to find point R that is somewhere on QS. So it says find point R 2/3 from Q to S. We need to be able to find that point by first finding the distance for the X values, so the change in the X's, and the distance for the Y's, so the change in the Y's, taking that entire difference between those 2 points, doing 2/3 of that distance, and then add it back to the original point so that you're going along that original line to that new coordinate. So I'm going to go through the steps. And again, we have our 2 X's. I'm going to call this, let's see. I'm going to call this X1, Y1. I'm going to call this X2, Y2. All right. So, first thing that we have to do, we are taking the change in X by finding the difference between those 2 X values. So, where I ended up was 10. That's my X2 value. I'm subtracting to find the difference, the -2. So I now know that my X value has changed by a total of 12. Because again, if you subtract a negative, that becomes adding a positive. So this is actually 10 plus 2, which is now 12. Then I do the same thing with my Y. Change in Y. Well, again, Y2 was -5 minus 4. -5 minus 4 is -9. That's the distance that I've moved on my y-axis. Now, yes, it's a negative. And although distance isn't negative, that negative is telling me a direction. I went a -9 units when doing my y value from Q to S. So, once I have found the distance that I've moved from Q to get to S, now I have to do the 2/3. So I'm taking this length, and now I'm going to be doing 2/3 of that length. So 12 times 2/3, and -9 times 2/3. When you multiply by a fraction, multiply by the top number, divide by the bottom. Or if you want to divide first and then multiply, that works too. So I could say 12 divided by 3, which is 4. 4 times 2 is 8. -9, again, I could multiply by 2 first and then divide by 3, or divide by 3 and then multiply by 2. -9 divided by 3 is -3, times 2 is -6. This is the distance, this is the change in X from Q to R. The original value that I had up here, that 12, that was the change in X from Q to S. Same thing down here. This original length, that's the change in Y from Q to S. This is now the change in y from Q to R. Again, this is the length. This is the length. The most common mistake that I've seen is people are taking this number and then putting it inside of parentheses. If you were to graph this at this point, if you were to take these numbers, make a coordinate point out of it, so I'd have the coordinate 8, -6, that coordinate's not going to be on the segment going between these 2 points. It makes no sense. This is just the length that I'm moving. So now, this value, that change, is what I have to add back to Q. Just like if I wanted to do from Q to all the way to S, if I added these original numbers to the values of Q, like 12, if I added that to -2, I would get 10. If I added 9 to 4, I would get -5. That's the distance I'm moving. This is now the distance that I'm moving to R from Q. So I take the original Q values of -2 and 4, and now I'm adding that change. So I have +8 and -6. -2 plus 8 is going to give me a point that is 6, and 4 minus 6 is -2. This is the point that I'm looking for. That is 2/3 from Q to S. Now, if you want to, you could even graph it to double check. So, let me zoom out just a little bit. And I'm going to make a graph of this so that you can see that this makes sense. So, I need to go back to -2, up to 10. Alright. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 1, 2, 3, 4, 5. 1, 2. It's -2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, graphing some points so that you can see that this actually does work. We have the point -2, 4. I'm going to use a different color. -2, 4 is my original point Q. -10, -5, 10, -5. That's point S. Then R is 2/3 from Q to S. So, if I graph that point, you should see that they are all in a line. So we have 6, -2, 6, -2, up there. Again, I'm not using graph paper, so it might not look perfect. But notice, I have, if I was to look at the slope here, from here to here, since we just talked about slope in our last chapter, so slope from, I'm calling this R, I'm going down 1, 2, 3, over 1, 2, 3, 4. If I follow that same pattern backwards, I should find other points along this line. Right? So instead of going down 3 and over 4, I'm going to go up 3 and back 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And look at that, I'm already back at Q. Here are some points on that line. And just to demonstrate, these are the only points that work on this line, right? So if you count the actual segments here, 1, 2, 3 different segment lengths, I am 2/3 from Q to S for point R. Again, all I really did with this equation here is I took the total change from Q to S, so this length here, I went over, so this is a visual demonstration now, I went over 12 units originally, and then down -9 units originally. So if I did 2/3 of this, let me use a different color. If I did 2/3 of this, 2/3 of 12 is 8. So if I only moved over 8 units, and then down the 6 units, that's 2/3 of the 9, I end up at R. So again, that's partitioning a segment. So again, the steps there, all you're doing is taking the overall difference in the x's, so change in x, the change in your y's, whatever that change is, multiply by whatever you're moving, so whatever that fraction is, that's now how you're moving. So you take that change and you add it back to the original point that you're starting from. So we added it back to the original Q values to get our new point. Now, I feel like I made this look complicated because I wanted to make sure I explained it in full detail. I'm going to do one more problem real fast from scratch where I don't show all this work because, again, you shouldn't have to do all this work in order to get there. So let's write an equation, or let's write some of the points here. So find point C that is, let's say, 3/4 from B to D. Now, I gotta come up with some points here, so give me a second. Let's say we start off at the point 3, -1, and we end up at, let's do 11 and -13. So this is what you'd be given for the problem. Again, I'm going to show a very small amount of work this time. Again, looking at this, I'm finding the change, so I'm not showing all my steps. The change in X, the change in Y. From here to there, I go a positive 8 units. From -1 to -13, I go a -12 units. So then what do I do with those values? I multiply them by the 3/4, which gives me, and 8 divided by 4 is 2, times 3 is 6, 12 divided by 4 is 3, times 3 is 9. These are the values I'm adding back to my original point. So I have 3 plus 6, and now, the second one, this would be a negative, because again, that was a negative number. I was going in a negative direction. So -1, -9, and my new point is at 9, comma, -10. And that's my answer. So again, I don't want this to make it look like it's really complicated, because it's not. It's finding the distance that you traveled for both the x and the y, multiplying it by whatever the fraction is that you're partitioning the segment with, and then adding it back to the original value that you started from. So again, that's all the work that you actually need in order to complete this problem. Hopefully that helps. Hopefully we get a good result on partitioning a segment on this next test, because you will see a question on it.